In this second video about graphing trig functions, I'm going to talk about some properties of these graphs. So first, I'll talk about vertical shifts. So say we want our sine function, but we want it to shift it up or shift it down vertically. Well, to shift our function up, we just add a constant to it. So if we're looking at the function sine of x plus 1, it's just the sine function shifted up 1, since we're just adding 1 to every value of sine. Similarly, sine of x minus 2 is just going to be the sine function shifted down by 2. So you can see sine of x plus 1 has a vertical shift of 1, and sine of x minus 2 has a vertical shift of negative 2, or is shifted down by 2. Next, we're going to talk about phase shifts. A phase shift is also a horizontal shift. So if we want to shift our sine function to the right or left, we're going to add a constant to the interior of our function. So we're going to add a constant inside those parentheses. So here, we're looking at function sine of x plus pi over 2, and this function is just shifted by pi over 2. And now if we're looking at sine of x minus pi over 2, this function will be shifted in the opposite direction by pi. And you can understand this by considering the fact that if we input negative pi over 2 into our second function, so into the red function, if we input negative pi over 2, well, negative pi over 2 plus pi over 2 is 0. And so then we would just get sine of 0, which is 0. So the second graph is just shifted to the left by pi over 2. Now for the third graph, so y equals sine of x minus pi, if we plugged in x equals pi, we'd get pi minus pi, which is 0. And so again, we'd get sine of 0 equals 0. So now we know that if x equals pi, we're at 0. So this is basically telling us that by adding a constant, we're shifting to the left by pi over 2. And by subtracting a constant, we're shifting to the right by that constant. Now, what about changing the frequency? Now, by frequency, I just mean the frequency with which our function crosses the x-axis. So we know that sine is a function which repeats itself. So between 0 and 2 pi, so we know that sine is a function that repeats itself. So remember that we can input values between 0 and 2 pi, and then after 2 pi, the values will just start repeating itself. So for just sine of x, we know that it takes between 0 and 2 pi for those values to start repeating itself. But say we multiply the inside of our function by 2. Now our function is moving twice as fast. So instead of just crossing the x-axis at 0, pi, and 2 pi, it will also cross at pi over 2 and 3 pi over 2. And similarly, if we multiply the inside by 1/2, our function is going to be moving even slower, or 1/2 as fast. Now just to look at a larger graph of this, you can see now we're looking at from 0 to 4 pi. We talked about this portion of the graph which repeats itself. So here for sine, it was between 0 and 2 pi, and then after 2 pi it started repeating itself again. Now this portion is called the period. So we say that for sine, it has a period of 2 pi. Since basically, if we look at any interval of length 2 pi, it's going to be the same since sine of x is equal to sine of x plus 2 pi for every value. So sine of 0 equals sine of 2 pi, sine of pi over 2 equals sine of 5 pi over 2, so on. So for sine, the period is 2 pi. For sine of 2x, the period is just pi. And for sine of 1/2 x, the period is 4 pi, since it takes until we get to 4 pi for our graph to start repeating itself. Now, another property of our graph is the amplitude. So if we multiply our function by a negative number, such as -1, it's going to flip the graph. So basically, instead of going from 0 up to 1, it's going from 0 to -1. So we just multiply each value of sine by -1. Another thing we can do is multiply our function by some positive constant. So if we look at y equals 2 sine of x, well, sine of 0 is 0, and so 2 times 0 is just going to be 0. So we still start at the same points. However, when we get to sine of pi over 2, which we know is 1, we're now multiplying that by 2, so we're twice as high. So multiplying our function sine by a constant changes the height that goes to. So it changes the height between the x-axis and the highest point and the x-axis and the lowest point. And similarly, if we multiply by a fraction less than 1, we're going to be decreasing the amplitude or decreasing the height between the x-axis and the highest and lowest points. So we can see for sine, our amplitude is 1. For 2 sine, the amplitude is 2. And for 1/2 sine, the amplitude is 1/2. Now, here's a general case. So we're going to let a, b, c, and d just be constants. Well, if we look at the function y equals a sine quantity bx plus c plus d, then we know that the constant a is the amplitude. The period is 2 pi over b. The phase or horizontal shift is negative c over b, and the vertical shift is d.